Hello! Okay, for this lecture, we will discuss heat effects in chemical processes. So in chemical processes, the heat involved is quite large compared to that in physical changes, diba? Chemical versus physical changes. Yung chemical process the heat change accompanying a chemical process is greater than the heat change accompanying physical processes. Ano bang example ng physical processes? Sensible heat effects. Yung phase change is a physical process. Latent heat of fusion. Sorry ulit. Yung latent heat, yung phase change, that's an example of a physical process. And then, yung sensible, yung temperature change, that's what I mean, yun yung another example ng physical process. Okay? During a chemical process, energy is stored in and released from the chemical bonds that form between atoms and molecules. Yan ang nangyayari sa chemical process. Stored in and released from the chemical bonds. Now, these bonds are usually much stronger than the physical forces between molecules, and they can store and release great amounts of energy. So, ang reason bakit mas malaki ang heat accompanying chemical process versus yung physical process, kasi nga naman mas malaki yung energy na nasa bonds ng chemical bonds as compared sa energy na nasa physical forces between molecules. We have heat effects in chemical process, namely heat of reaction, heat of formation, and heat of combustion. Oops. Okay. Heat of reaction. Sige. Sa heat of reaction, we have reactants entering at T0. And then, pwedeng yung Q papasok or pwedeng palabas. Depende sa reaction. If exothermic or endothermic. Then, lalabas yung products at T0. We can measure the heat of reaction using an isothermal flow calorimeter. Since the process is carried out at a constant pressure and no shaft work is involved, Q is just delta H. Okay? Constant pressure, tas walang shaft work, so walang work. Yan yung heat of reaction. Difference in enthalpy between the products and the reactants at constant temperature. Standard heat of reaction. Consider this balanced chemical reaction. Okay, kunwari, chemical reaction yan. The standard heat of reaction for this reaction at the temperature is defined as the enthalpy change when reactants in their standard states at a certain temperature react to form the products in their standard states at the same temperature. Ano ba? Let's define ano ba yung standard state. It's a state of a species at a temperature T and at a specified condition of pressure, composition, and physical condition. Example ng mga substances in standard state. For gases, pure substance in ideal gas state at 1 bar. or liquids and solid, pure substance at 1 bar. So when we say yung heat of reaction, it's defined for a particular stoichiometric coefficient of the reaction. So dapat may particular stoichiometric coefficient siya para masabing when we're talking about heat of reaction. And kapag yung heat of reaction mo is in standard state, nilalagyan natin ng symbol na degree. Paano ba example nun? Ayan, ito, yung standard heat of formation at 298 Kelvin. So, it would be impossible or impractical to list down all of the heats of reaction ng lahat ng possible reaction. Diba? Ang dami-daming pwede kasing heat of reaction. Unless, siguro mas makapal pa sa peri kung ililista din lahat yun. Kaya, kasi nga, maliban doon sa reaction, pwede rin sa ibang temperature. Kaya may standard set of heats of reaction na lang para makalculate natin yung heat of reaction. So, paano ba natin gagawin yon? Let's first define a formation reaction. It's the reaction which forms a single compound from its constituent elements and produces 1 mole of the product. Example, para ma-produce to, ano ba to? CH ethanol. Yan. Ito yung reaction para ma-produce siya. Para ma-produce ang carbon dioxide, ito yung reaction. At saka sulfuric acid. Yan, question mark kung ano yung state niya. Therefore, heat of formation is based on 1 mole. Dapat base siya sa 1 mole of the product. And by definition, heats of formation of elements are 0. So, please remember na heats of formation of elements are 0. And kasi sila yung reference point for defining the heat of formation of everything else. Usually, heats of formation are tabulated at a standard temperature, 298 or 298.15 Kelvin. So, yun yung standard temperature. Now, the standard heat of reaction, ito siya, meron ding degree symbol at 298. Ano siya? Heat of reaction when the substance is formed on its standard state of temperature, which is 298 nga, from the elements in their standard states of temperature. Yan. Let's say we have the generic reaction. Ito yung heat of reaction yan. Diba yung number of moles times the heat of formation of L plus number of moles ng product, okay, na M times heat of formation ng M minus na, okay, minus, so ito ay product minus yung sa reactants na to. Number of moles times heat of formation ng A minus number of moles ng reactant na B times heat of formation ng B. Or, in other words, the summation of the heat of formation of the products minus the summation of the heat of formation of the reactants. So, for example, we have partial oxidation of methane to give synthesis gas. Ano ba yung synthesis gas? Compose yan ng carbon dioxide, Yan, tsaka hydrogen gas. Synthesis gas yan. So, partial oxidation ng methane to give rise sa synthesis gas. We can write it as the sum of the following reactions. Yan. So, C plus 1/2 O2 equals CO, tsaka CH4 magiging C plus 2H2. So, pag sinam natin yan, yung left side, ito, tsaka yung right side ng arrow, magiging ganyan. Tapos, from the table ng standard, puntahan natin kay Van Ness. Ito, heat of formation. Carbon monoxide. Ito siya. Heat of formation of carbon monoxide, negative 110,000. Kay Vanis pa rin. Okay. Then, sa CH4, bakit iyon lang yung nilista natin? Ba't nga ulit? Ba't ito lang, tsaka ito? Kasi elements ulit. Delta HF of elements are 0. Sige. So, yun lang yung nilista natin. Therefore, para makuha yung delta H ng reaction at standard nito, ito, para makuha yung delta H niyan, diba, yung products, delta H ng formation ng products minus delta H ng formation ng reactants. Nagkataon lang na sa balance reaction, ano siya, wala siyang coefficient. Hindi wala. 1 yung coefficient, kaya hindi kailangan i-multiply. So, 1 lang ma-multiply. So, minus, since negative din to sa methane, kaya naging positive na to. At to yung magiging result. Okay? Yan nga. Standard heats of formation of different substances ay nasa table nito sa Van Ness. Okay. Alam na natin to. Heats of formation of elements are 0. Then, pag nagsusulat tayo ng chemical reaction, do not forget to state the physical substance. State of the substance. Physical state of the substance. G for gas, L for liquid, S for solid. Bakit? Kasi may ibang substance na nag-e-exist sa iba't ibang state. Bawa ito, si ammonia, meron siyang gaseous, meron siyang aqueous. Yun, edi, pag di mo sinulat, lagot ka. Kakamali ka. Ganon. So, dapat alam mo yung state niya. Kasi, baka maiba yung mapili mo na delta H. F. Punta naman tayo sa standard heat of combustion. Most formation reactions cannot be carried out in practice. So, heats of formation usually have to be determined from calorimetric measurements that can easily be carried out. And the most common class of reaction that goes nicely to completion is combustion reaction. Yan. Example ng combustion reaction is combustion of hydrogen para maging water. Or we can burn graphite directly para maging carbon dioxide. And then, the formation reaction of water and carbon dioxide are the same as the combustion reaction of H2 and C. Bakit? Kasi, diba, formation reaction nito is combustion reaction lang nito at ito. Yan. Yan lang ibig sabihin ng first sentence. So, the heats of formation for H2O and CO2 are equal to the heats of reaction that we measure for the hydrogen and carbon combustion reactions. And both are the same standard state conditions of 25 degrees Celsius and 1 bar. So we get the standard heat of formation for CO2 is this value and this value for water. Therefore, by burning all sorts of compounds made up of CHO, we could determine their heats of formation indirectly from the heats of reaction for the combustion reaction. Bakit? Paano? Because we know the heats of formation of carbon dioxide and water. Okay? So, para magets natin, yung next natin sa next video ay sample problem.